Hi, welcome. Today is Friday, March the 5th, here at Spain Park, AP Chemistry. This is a unique recording of 6th period instead of 1st period.
We're better.
Okay? So, again, a little different flair, a little different class atmosphere going on in here today. So, when we're looking at this first question, when you increase the volume of a container, what does the equilibrium, how does the equilibrium adjust to that stress?
It favors the side with
Okay,
more
Angel,
moles.
what?
Yeah. It favors the side with more moles.
Of gas. It's got to be more moles of gas because, okay, so this is 0, solid and liquid, going to 2. That's actually your answer. What is this one?
The same.
2 to 2. This one, this is the one here why you have to pay attention because it's 9 moles of gas here, but
4.
it's only 4 moles of gas here. If you read 10, then that can be a common mistake is you think, well, it increased in moles, but it's not moles of gas. And then this one went from 3 down to 2, so it decreased. So the answer is going to be A. So the key on that one is it favors the side with more moles of gas. So on your test corrections that we're going to do, if you miss this one, you put answer A because the equilibrium will favor the side with more moles of gas. That's your explanation. You don't just put A. All right? What do we do? What do we do here? This wasn't very highly missed, but if I'm going to go to this equation right here, okay? First off, I know I'm going to be adding these together to get this one, so I know I'm going to multiply my K's. But what did I do to this equation to get to this one?
Flip it.
Times 2 and flip. So if I multiply by 2, what do I do to K? Square it. And then if I reverse it, 1 over. So it's going to be 1 over K1 squared. And then this one, we just reversed it, right? So it's 1 over K2. So it's going to end up being the 1 over K1 squared times K2. It really does not apply to anybody in here, but there is going to be a retest. For those of you watching at home, there is going to be a retest, but an 80 is the highest grade that you can make. And I think that's the only fair thing, so the people that did well on the first go-around. If you make an 85, you'll get an 80. If you make a 100, you'll get an 80. If you make a 75, you make a 75. Okay? So this is just a chance for you to take a second shot at it and get your grade from a 50 to an 80. So hopefully it won't be quite as damaging to the grade. Okay, but more importantly, it's a second chance to demonstrate that, okay, I understand it now.
So it's people at home that are failing it?
No,
they have open everything.
So, anyway, but nobody in here would that benefit. All right, number 3. You guys pretty much got that one, okay? We want to go reaches equilibrium, which of the following cause an increase in the number of moles of PCl5. So in other words, we want it to come this way. Decreasing the volume. Well, yes, that's going to shift it this way. Raising the temperature. No, that's going to shift it that way. Adding a mole of helium. No effect. So it's 1 ohm. All right, number 4 was more highly missed. Not necessarily in here, but this is that KP. What's the key phrase in this one? Okay. No.
Decomposes.
Initial pressure and total pressure. When you see total pressure, whose law do we have to use? Dalton's law. Okay. So, who's my shine over here, please?
Me? Oh, I thought you were. Okay.
Okay, so the first thing is we read the question. What is the KP? So KP we know that Kp is gonna equal the pressure of the PCl3, yeah, make sure I put that right, times the pressure of the Cl2 divided by the pressure of the PCl5. Okay, so that's my ultimate question. Obviously, if I'm gonna find Kp, somehow I have to know these three values. That's step one in solving this. Step two, I know that the total pressure, I do my ice table. PCl5 goes to PCl3 plus Cl2. I start with 1 atmosphere. 0 and 0. What's my change going to be? Minus x plus x plus x. So at equilibrium, I have 1 minus x, x, and x. So how do I find out what x is? Because the total pressure is the pressure of the PCl5 plus the pressure of the PCl3 plus the pressure of the Cl2, which is going to equal 1 minus x plus x plus x. So the x equals 0.6, right? So that means now this is going to be this, 0.6, 0.6, and this is going to be 0.4. So we come back then to this, so it's going to be 0.6 squared divided by 0.4. Now you would really be doing this without a calculator on the AP test. 6 times 6 is equal to
36.
36 divided by 4,
9.
9. The only one with a 9 is that one. Okay, that's a long problem for multiple choice, but you know, welcome to AP. We did several like that, so we got to make sure that we are comfortable doing that one. All right, now we'll skip 5 and go straight to 6. 6 was by far the most highly missed. You guys actually did remarkably well on that one.
But it looks like more people missed it in 4 than 6. Because there's only 4 on the top.
Well, there's 9 plus 3
Oh.
makes 12.
Oh, I thought those were scribbled out.
No, yeah, well, it's because I put one of these up there at first, so I had to scratch the 5 out and go back to 4. It's a complicated data collection system.
Yes, I see that.
I call it Hopstron instead of a Scantron. So we have 4 HCl's plus O2 goes to 2 Cl2s plus 2 H2O's. Now the key word in this is must be. Not can be, but must be. That means all the time. So when I have a situation like this, I put in numbers, just randomly pick some numbers. It says equal numbers of moles of HCl and O2. So I'm just going to pick 10 as my initial. 0 and 0. Because these are 0, to go to equilibrium, what's the way it has to go? To the right. So what's this going to be? Minus 4x minus x plus 2x plus 2x, right? So at equilibrium, the question is, HCl must be less than Cl2. Well, do we know which way the reaction is going to go? Do we know if it's product favored or reactant favored though, I mean? No. So let's just say that only 0.1 mole went. Well, then that's going to be 0.4. This is still going to be 9.6. This is only going to be 0.2. Okay? Now, if 9 moles, x equals 9, well, x really 2.5, or let's just even say 2 just to make it more realistic. That's going to be minus 8. That's going to be 4. So then it all depends on whether it's product or reactant favor. So it doesn't have to be greater than or less than. So that one's out. O2 must be greater than HCl. O2 must be greater than HCl. Well, no matter how much, if 0.1 reacts, 0.4 of this is going to be gone, where only 0.1 of that. No matter how much, because it's 4 to 1, that statement is true. Always. And then Cl2 must equal H2O. Well, it's 2 to 2, so they're always going to equal one another. So just put in numbers. And when you're trying to pick on the must be greater than or less than, put in a small, super small number, put in a max number. And just kind of see how does it work out both ways. Okay, that's just test taking.
So the answer is D then?
The answer is 2 and 3.
Yeah.
Yes. All right, 2 more. Great. This problem though actually was in your, we did this in class.
We did.
Okay? We did the exact same problem in class. I debated, I said, you know, they probably won't remember. Okay? But this is the same total pressure one here, but this is the one here, as the reaction progresses towards equilibrium, what's gonna happen? What happens to the rate of my reaction? What's the graph of concentration versus time gonna be? What's it gonna look like? Okay? Jaden's giving me the hand signal. It's gonna look like this. Okay? To where you're gonna start off with a certain rate, but the concentration is going to be decreasing over time, so the reaction's slowing down the concentration over time. Okay? So, but does it, when it reaches equilibrium, does it stop? No, so it's gonna decrease, but not to 0, so we can eliminate increase and stays the same. We know that forward rate's gonna slowly decrease, but it's not gonna decrease to 0. It's gonna decrease to some non-zero to where the forward and the reverse equal one another. So as the forward rate decreases, the reverse rate is increasing. Until, I did that wrong. It'll look like this, as far as rates. Because eventually the forward rate and the reverse rate are gonna equal one another. Okay? Does everybody understand that one? It doesn't go to 0. And then here, this is calculating the Kp again, doing the exact same type of problem using the P total. All right. Just bear with me just a few more seconds. I want to see, I thought I had my short answer questions. I have those. I have the problems. Still don't have the short answer questions. I have everything but the page I want. It's got to be in this problem. When we're looking at these questions, we have, okay, we have our equilibrium up here. Raising the temperature. This is one that I may not have made perfectly clear. Since this is negative, so is it endo or exothermic? So where's heat? On the right. So if I increase heat, it's going to shift the reaction left, right? Correct? So what is that? That means reactants are going to increase, products are going to decrease, so K is actually going to decrease. It's going to become more reactant favored. So an increase in temperature does not automatically mean an increase in the value of K. Depends on which way it shifts the reaction. If it's always going to favor the endothermic direction, so in that case, since it's shifting it left, K decreases. So temperature is the only thing that affects it. So no effect to K, no effect to K. And by the way, you gotta make sure you answer the question because it asks for K and moles. Okay? Helium has no effect. A catalyst gets you to equilibrium faster, but has no effect on the position of the equilibrium or the equilibrium constant. So DNE is no effect. Now F's a little bit more complicated because you guys are did well. It's not gonna take you as long. I wanna just kind of talk about this one. SO2 plus O2. So it says removing some SO3. So this is gonna go down. So what's the equilibrium gonna do? It's gonna shift to the right to replace it. And it's gonna come back up. But it's because these values are going down to keep the ratio the same, this is not going to come up all the way back to where it was. So it's actually, I mean, it's kind of an obvious thing. If you remove some SO3, the amount's gonna decrease. But I didn't even count whether or not, you know, because most everybody's gonna say it's gonna want to shift right, which is the key. So you take some out, it's gonna come back, but it doesn't come back all the way to where it was. Because we didn't change the temperature, so K still has to equal the same ratio. These numbers are going down, so this one's coming up, but it can't come all the way back up, otherwise you'd have too much product, K would be getting bigger. Okay? So it's kind of a, you know, kind of a balancing act. All right. Let's work on test corrections for any of the free response that you missed. Answer it completely and fully. Resolve the problems that you missed. Okay? And then put your corrections on top. In a little bit, I'll go over the bonus with you as far as, and that'll help you with the lab, the percent NaCl lab, the problem. So once you finish test correction, start working on finishing up that lab, all the calculations and that question. And then we'll talk about it. And if you're finished with it, then you can turn it in today, but it's not gonna be officially due until Monday. Yes, ma'am?
Are you still not grading the last problem?
Yeah, 6 and 7, you don't have to do. Okay? Now, in the as far as calculations on there, because we haven't done that yet, but I do want you to do the problem. That was on which will prove which one precipitates first. But when I go over the bonus, that's going to help explain more how to do those. All right? Okay, here's one.